Hi again, part 3 tutorial of OpenGL in Python. Previous video we draw basic shapes, so we will just remove everything that we prepared before because we will not use it anymore, and we will do a little cleaning and the translation we say or before matrix mode the model view, we translate and we do quick saving to matrix. This will tell OpenGL to store current translation and rotation which corresponds to the OpenGL model view matrix. So I will comment this for you. So this is matrix mode we select now. We do translation in this matrix and we say OpenGL save this matrix for us. So basically it creates copy of this matrix and puts it on the top of the stack. So we can do translation, rotation on everything on this matrix and then just call GL pop matrix to go back. Yeah? But we will not do this at this point. But I want you to draw, because we draw basic shapes, but now I will show you how to draw cube with a wireframe, some depth projections, and there was one more thing I wanted to show you. Okay, so let's define our cube first. I had somewhere this clever code, but I don't need this now. I need this for the faces, but we will define our cube vertices, if I'm not mistaken, and we will define by array. We will make list, unpack our generator. Our generator will be product. This is the thing we imported before, and I add also cycle import. We will use it later for colors, but for now we will use this product iterator, which will generate us our cube points. So we will define points -1 and 1, and we will tell product to repeat this 3 times. So basically we want to have every, not pair, but triplet containing each combination of these two values. So as you will see after it, can print cube vertices, and you can see that we got -1, -1, -1, and none of this is repeating. Okay, so this is some smart trick to render it a little better, so you got no chance to do it wrong. I mean, you can do it wrong, but you can't lost minus or instead of ones, do -1. So let me quickly put this on right side of the screen because I need to check something. Okay, so we got this blank. Okay, so we got 8. We got 8 points and 3 coordinates, but we have to transpose this. We have to use simple T of numpy, make this matrix collection of vectors. So our point is to have X, Y, and Z in this shape. Yeah. So we got point 1, column 0, point 2, and go on. Yeah. This will be very helpful when doing math translation. We'll see in a moment. Okay, so we got cube vertices. We will also need faces, defines our connection between these points to draw faces. You know, these planes that will be full of code, I mean full of color. So this now I will also paste few stuff so you can actually see. Oh, why do you want? Sorry, it's some Vim problems. It lost my clipboard. Okay, once more. Not like this, more like this. Okay. So let's adjust it a little bit. And shortly, but with full details, we got these edges that will connect just points and draw wireframe or skeleton of our cube. And we got faces defined by hand. No big deal. Okay, we got also some scaling that I don't think I need. This no. This is totally unwanted. Right? Okay, so you got this some fancy loops and faces defined because I was lazy. So we now print edges and run it on the screen. You will see that vertices are not defined. Okay, let's rename this variable. Okay. And also in this place. Okay. Let's see if this works. If I could spell it correct, then it would be a little better. Where okay, it's now drawing, and we can say this is empty. Why is this empty? Is this because of too early transposition, maybe? Yes. So you can see we got values now. Okay. So after finding these edges, we can now do cube vertices. Vertices transpose, okay? And we will now have vectors instead of rows. So, to draw a cube, all we need to do is, let's say we choose color first, okay? Maybe some just one color just for this first drawing, and we say GL begin. You will say begin pipeline of GL lines. I need big capitals. GL. And we will now iterate over our edges. For edges, we got vertex 1 and vertex 2 in edge. And we just simply, if I remember correctly, we will have three-dimensional vertex, so we just draw vertex 3f vector vert1 and vector I think my keyboard is not working properly. Okay. Now we draw our two connected edges. We can check if it is working correctly, and it's not working correctly. Right. Because vertex has no information about position, but we just stored our indexes. So there is index 1 and index 2, and our vert will be our cube box full of vertices. And we say we want every row at index 1. And we go duplicate this line and put index 2. Okay. And now if we render this stuff, you will see that we got projection of our cubes. Okay. Let's add some colors and more faces to it. So firstly, we will define static colors to select from. So we will say numpy random, and we will define our, I don't know, 20 colors, and RGB is 3. And we will use these colors not in this place, but when drawing faces. GL, so we start new pipeline, GL quads for this purpose, and also end. And we'll do the same for faces like for edges. For face in edges, very similar, but we do for vert in face because we got 4 vertices and it's same code, so we can make loop inside the loops. Oh, no big deal. Vertex tree f vector and cube vertices, everything and vert. Okay. So in the addition, we can color our box in two styles. We can color face to be one solid color, or we can, during this drawing for vertices, we can color here. So every vertex will have different color, and it will just smoothly change over whole face. If we wanna, yeah, we can do this. You can see we can do this now. So we need for sure more. I don't know. Let's say we need 30 colors because we got for 6 faces times 4. This means 24. So 30 will be enough. And for colors, because this loop will be endless until we break it, so we also need a cycle that we imported before. So we make colors equals to cycle. I believe this will work because it will fetch items from this numpy array. No, then we will come back to this line, but I think it will work. So all we have to do now is say call equals to next from colors. Okay, and we say GL color our code. Great. Let's see if this is okay. Okay. First things drawing. I can see that we got some connection problems. I don't think this vertex is properly connected. Only 2 points in the face. Why is that? I see. We got face in edges, but this is not correct. We need to iterate over faces. Right, so we did face in faces, and okay, let's undo and change the color. This is not okay, and let's save it, let's run it, let's see it. Yeah, it's working. So it's blinking because we don't have equal colors, so they are just this cycle. We got 6 more colors than we need to. Then we have, okay, let's just select 24, as I said before. It should be exact number of our colors. Yes. So with every global while, we select first color for first point and so on. So this is our skeleton and faces of the cube. Now we can do some fancy stuff and rotate this. So we got 2 options. We can do you see this? We can move things around, or we can rotate whole world around. So to give you a reference what is going on, we will also draw under our cubes, we will draw 3 more lines that will indicate our directions. So let's define origin offset first, and we will say we can also do tricks here. No, not now. Let's say x2, 0, and -1 maybe. Okay. And we begin our GL lines. We want x red, y green, z blue. Okay, and we set these colors. So red, we then draw vertex 3f from 0 to oh no, wait. We actually do a little different, like this. Let's make this array. This will make something easier. So our offset is array. We will draw first point as origin offset, and now we will draw also vector and origin offset plus our x-axis, which is basically 1 in x direction and 0, 0 and the other two directions. And we will copy these 3 lines into green side. Okay, we will change color to green. We will leave our offset and change y direction, and so on with blue, also small modifications. Okay, we had GL in, so we can now GL end. Okay, and as you can see, we got a little too far, but we can see green, red, and blue. If we also add GL line width, then we will spot this a little easier. Also, this line width is applied to our box. So now I will demonstrate you some simple tricks, or I don't know, something. Yeah. So first we can do something called GL rotate, and we'll say in degrees, we'll say 1 around some axis. We will say around top, so it's y-axis, and this will rotate our view. We need to clear buffer and depth buffer so you can see. Okay, so the drawing stuff, we say GL clear, I remember correctly. I don't have open this file. Let me quickly look for the flag I need to clear, because it's not obvious. GL color buffer bit, and we do OR operator with GL depth buffer. Okay, you can see there is pattern. We got GL, some name, and buffer bit. Okay, I will show you what will happen now, and we can also fix this in the moment, as we also slow the rotation, because oh no, it's rotating so quick because we don't actually slow it down anyway. So when we at the end we got pause, but we call else and say pygame time wait 50, and we also change this sleep, because there is no sleep in pygame, to wait. Okay. Save it, run it, and we can see it's rotating. And there is one problem. The origin axis is rotating, so tells us that we are rotating. And the second problem is that the box is very weird, as you can see, because we got this face and this face, but this should be behind, and it's not. Oh, you can see this green space in the front of it. So you can graph face by face, write your own algorithm for it, for calculating distance between you and the object, but the easier solution for it is actually just to enable OpenGL depth. So we call enable, and we call GL depth, called test for some reason. Now, if we render stuff, then you will see that we got front faces only showed to us. Okay. So everything is rotating. Axis is offset by 2 in X direction, so it's not in the middle. We can quickly change this to be 0, 0, and we will modify our box. So before driving box here, we will say that this is not cube vertices, but cube matrix, because we will modify this. I want oh god, I have to now let's keep this way and modify the other one. So this will be cube matrix is cube vertices and copy. So we can now actually add values and don't care if it's modified. So let me just replace the keywords here. This is cube mat. This is also cube mat. And this one, okay? As we can check it if this is correct spelling, okay? It's showed. So we can do simple, because we got these vectors stored in our matrix like this. Just have to add vertical vector with some offset to offset every value in some row. So we just call cube mat plus, and by array 2-dimensional, we say we want to move it to the side. So let's say 2 in X direction, and everything is 0. And we also have to transpose it to match the dimensions. Yeah. So now, as you can see, our origin is standing in place and just rotating. Okay. So box is not rotating, it's standing in place, but our camera is moving around. You can change things. So let's just let me think what I want to do. I want to keep our frame in the position without rotation, and I wonder if I want to just move box around or move and rotate, because these two types of movement are different. Well, let's say maybe from something simple, so let's just move around this box without affecting any rotation. So to do this, first let's remove this rotation. We don't wanna anymore. We want our camera to keep this one position. Okay. Now we will add push matrix to store our camera position, and after rendering skeleton box and skeleton and cube faces, we will call GL pop matrix to retrieve our saved state before. Yeah. So between these two commands, we can call any translation, any rotation. We can even call reset matrix, so it will be default from as in the beginning. Now we can translate this. Yeah, let's start from translation because I said so. So call translate, and I mean translate, and we can use some mathematical function. Maybe it will be, I think it will be the best. So let's say translate is mat cosinus the angle, mat sinus angle, and 0 in. Oh no, we can do this in back, I think. Okay, let's just try if this works. We need to pass radians to it. We will get angle from math radians. Input we can use time, and let's say we don't want a 1 degree at 1 second. Let's say 30 degrees and 1 second, and let's see what happens. Angle is not defined. Fair enough. Okay, we cannot call translate v. Okay, so let's just unpack this. And trans is not defined. This is transl, translation, and trans f for transformation. This is what I keep in my mind. Okay, so the box is moving in circles. We are driving same box over and over, but with some offset. You can also increase the amplitude of it just by scaling this cosine and sine function. We can also call both as cosine function. There's no problem with it. And we can see that the movement is different. Mat and cosinus are connected in geometrical way. So now you don't see any circular motion, but you see this motion. Okay. We can also make some rotation. Let me think. We can also make, because we saved this, we can load like then. Oh no, wait. Are we even in correct matrix mode? I don't think so. Okay, let's make sure we are in GL model view, because we don't wanna mess with projection at current state. So we switch to matrix mode, we push our matrix and we load default one. So now if I render this, I'm not even sure what will happen, but we will adjust this in a moment. I'm just I'm just curious what will happen. Okay, so we saw a box for a moment that just goes by our screen, but this is not what we want. Okay, I want signs. I want this to be circular motion, or maybe some elliptic. So we scale this by 5 and the other by 3. Now we got this identity matrix, and we can add some. Instead of translation, we will first add rotation, and let's say we use. Oh no, this is in degrees actually. So we'll say deg math and degrees. I'm doing this way because I had some problems with using time just directly to the rotate function. So just do this way, deg as degrees, and let's rotate around x-axis, and then we call GL translate, because we have reset our view with load identity. We are very close to the 0 point. We will translate again to some deeper positions, and this translation to our box. Let's see if this is what we wanted. No. This is not what we want. How our degrees look like. We push matrix, we pop matrix, this is fine. Got kind of big degrees that I do not like, so let's modulo this to 60. And it's still not showing anything. So maybe this translation has to be negative, actually. Yeah, it has to be negative. Okay. So let's say 20. Or it's very far away. Maybe I have to translate first and rotate, but this will be the same as initial matrix. There are some movements like this, but the problem with this is that we are moving in this circular motion and rotating around x-axis, but it's more tricky if we want to rotate around center of the box. For this problem, we could use actually the rotation matrix itself. So let's actually disable this 3 rotation and translation. See if we are back. We need also disable load identity, and let's go back to circular movement or elliptic kinda. Yeah. So to make this box rotate about itself, we can modify just vertices, and to do this we will use simple simple linear algebra math. So I think I'm repeating very much. So we got our cube map offset here, and we got copy here, but we have to, I think we have to rotate it before translation. So cube mat is numpy dot, and we will leave blank it for now, and we will define our rotation matrix, which will look like you will see in the moment. It's three-dimensional. We define, let's say, about y-axis, so there is one in y axis. On diagonal is cosine angle, in y is 0, and there is sine in this position, and also there is sine in this position, 0 and y, and cosine on diagonal. I mean mat cos, not cos mat. Okay, and we have to put one minus, and the from x to z is minus is here. Okay, so we got our rotation matrix, and we can apply this rotation from the left side. It has to be from the left side because you cannot change order of the multiplication matrix as you want. Not every time. But we got, I hope we got mat in vectors here also, but we will see in a moment. And we also need our angle stuff, so let's copy it back here, or even maybe, yeah, even here. And delete this, this is, the degrees are not needed anymore. Okay, and let's see. Okay, you see, box is floating as it was before, and now it's rotating itself around its own axis. So I can prove this by disabling rotation, so you can actually see that it's rotating in a position. Yeah, awesome. So you know how to draw lines, how to apply depth, so how to move it, how to rotate stuff. There is very much things you can actually do with it. Yeah, and if you want, there is also this one thing I see. We can also disable some depths when drawing some stuff. So we can actually use depth test for drawing box like that. And we can quickly disable this when drawing our origin axis. So we call it GL disable, GL depth test. And let's see if we enable this in the loop. Okay. So our axis is in the front. and boxes behind as we want. Okay, so stay tuned for next video. I will probably do orthographic projections maybe, or modern GL. I don't know yet. I hope you had fun. See ya.